The last time I paid for water was in 2005. I was at a gas station outside of Missoula filling up my truck for what turned out to be the last time I ever filled up my truck. I bought a 24-pack of bottled water for $4.99 because I was driving into the Bitterroot Mountains to live on a piece of raw land with no well, no plumbing, and no running water of any kind. I thought I would need that water to survive the first few days while I figured out my next move. I drank 3 bottles. That was it, 3 bottles. Because on my second morning on the ridge, I found something that made the other 21 bottles pointless. A spring, not a creek, not runoff, not standing water, a spring, cold, clear water pushing up through fractured granite at a rate I later measured at roughly 2 gallons per minute. It has not stopped flowing in 21 years. Not in August when the creeks dry up, not in January when everything on the surface is frozen solid. 2 gallons per minute, 120 gallons per hour, 2,880 gallons per day. That is more water than a family of 6 uses in a week. And it comes out of the mountain already filtered through 200 feet of rock at a temperature of 38 degrees year-round. I have been drinking it every single day for 21 years. I have never boiled it. I have never treated it. I have never filtered it through anything I built or bought. And I have never once been sick from it. Not once. I want to walk you through exactly why that water is clean, how I built a system to move it from the spring to my cabin without a pump or a single dollar of electricity, and why the $50 billion bottled water industry is selling you something that comes out of the ground for free in almost every mountain range in America. Stay with me until the end, because the last thing I am going to explain is something about your tap water that most people do not know, and when you hear it, you will understand why I would rather drink from a hole in the ground than turn on a faucet in any city in this country. Let me start with the spring itself, because if you do not understand what a mountain spring actually is, you cannot understand why the water is safe. A spring is not a puddle. It is not surface water that collected in a low spot. A spring is groundwater under pressure. Rain and snowmelt on the mountain above me seep into the soil, pass through layers of organic material, sand, gravel, and eventually reach the bedrock. The water follows the fracture lines in the granite, moving slowly downhill through the rock under the force of gravity. At the point where a fracture line intersects the surface of the slope, the water emerges. That is a spring. The water I drink fell as rain or snow somewhere above my ridge, entered the ground, and spent weeks or months traveling through hundreds of feet of natural rock before it reached the surface at my spring. That journey is a filtration process more thorough than anything manufactured by any company on Earth. The U.S. Geological Survey has studied mountain spring water extensively. Their data shows that water emerging from a granite spring at depth typically contains fewer than 1 coliform bacterium per 100 milliliters. The EPA maximum for safe drinking water is 0 detectable coliforms per 100 milliliters. but their own testing acknowledges a practical detection threshold. Spring water from deep granite sources routinely tests at or below that threshold without any treatment whatsoever. Compare that to municipal tap water, which is surface water pulled from rivers and reservoirs that has been treated with chlorine, chloramine, fluoride, and in many cases still contains detectable levels of pharmaceutical residues, agricultural runoff, microplastics, and heavy metals that the treatment process was never designed to remove. The Natural Resources Defense Council tested over 1,000 bottles of 103 brands of bottled water in a landmark study. They found that roughly a third of the brands contained bacterial contamination, synthetic chemicals, or arsenic at levels exceeding state or industry guidelines. A third of bottled water that you pay $2 a bottle for. My spring water tests cleaner than the product those companies are selling, and it costs me nothing. But finding a spring is only the first step. The spring on my property is about 340 yards uphill from my cabin. On my second day up here, I was walking to the spring with a bucket 3 or 4 times a day and hauling water by hand. That is roughly 70 pounds per trip at 4 trips a day. After a week, my back was in agony, and I was wasting 2 hours a day on water hauling alone. I needed a system, and the system I built cost me $5 and 1 weekend of work. The principle is gravity. My spring sits at approximately 6,340 feet elevation. My cabin sits at approximately 6,280 feet. That is a 60-foot elevation drop over 340 yards of distance. Water flows downhill. That is the entire engineering concept behind my water system. Gravity feed, no pump, no electricity, no moving parts. The Romans built aqueducts on this principle 2,000 years ago that carried water for miles across valleys and through mountains. My system is 340 yards of pipe running downhill through the woods. The Romans would have laughed at how simple it is. The pipe is where I spent my $5. At the same junkyard where I bought the steel plate for my cooking setup, I found a pile of old copper tubing that had been stripped out of a demolished house. Various lengths, some bent, some corroded on the outside, but structurally sound. The junkyard owner sold me the whole pile by weight, $5. I spent a Saturday straightening the lengths I needed, joining them with friction fittings I made by slightly flaring one end of a tube and pressing the next section into it, and sealing each joint with pine pitch mixed with animal fat. Pine pitch is a natural waterproof adhesive. You collect the resin that bleeds from wounded pine trees, heat it until it liquefies, mix in a small amount of rendered fat to keep it flexible when it cools, and apply it to any joint you need to seal. It hardens within an hour, and it does not dissolve in water. I have joints on this pipe system sealed with pine pitch that have not leaked in 21 years. I trenched the pipe about 8 inches into the ground for most of the run. Not deep enough to be a major digging project, but deep enough to protect the pipe from falling branches and to provide some insulation against freezing. At the spring end, I build a small stone catch box, about 18 inches square and 12 inches deep, lined with flat rocks and sealed with clay. The spring water rises into the catch box, fills it, and the pipe inlet sits about 2 inches below the water line, so it always has a full feed. At the cabin end, the pipe comes through the wall and terminates in a simple wooden spigot I carved from a piece of larch. You lift the spigot handle and water flows. You push it down and a tapered wooden plug seats into the pipe opening and stops the flow. That is my plumbing: a copper pipe, a stone box, and a wooden spigot. Total cost, $5 and a weekend of digging. The flow rate at the cabin end is about 1.5 gallons per minute, slightly less than at the spring because of friction loss in the pipe over 340 yards, but more than enough for every need I have: drinking, cooking, washing, cleaning. I fill a 5-gallon wooden bucket in about 3.5 minutes. I use roughly 8 to 10 gallons a day, which means my spigot runs for about 7 minutes total per day. The other 23 hours and 53 minutes, the water backs up in the pipe, stays pressurized by the elevation head, and waits for me. No energy consumed, no wear on any component. The system is doing nothing when I am not using it, and that is why it lasts forever. There is nothing to break. Now let me talk about winter, because that is the question everyone asks. How do you keep a water pipe from freezing on a mountain in Montana where the temperature regularly drops to 20 and 30 below zero? The answer surprised me, because I expected it to be a serious problem, and it turned out to be almost no problem at all. The pipe is buried 8 inches underground for most of its length. The frost line at this elevation in western Montana is roughly 36 inches, meaning the ground freezes to a depth of about 3 feet in the coldest part of winter. My pipe is well above that frost line. By all logic, it should freeze solid. It does not. The reason is that the water in the pipe is constantly being replenished from the spring, and the spring water emerges at 38 degrees year-round. Even when I am not drawing water, there is a very slow seepage through the spigot joint that I intentionally left slightly imperfect. A tiny drip, maybe a quarter gallon per hour. That constant trickle of 38-degree water moving through the pipe prevents the standing water from reaching freezing temperature. Moving water resists freezing far more effectively than standing water. The University of Minnesota's Cold Climate Engineering program published data showing that water flowing through a pipe at even minimal rates can resist freezing at ambient temperatures 15 to 20 degrees below the freezing point of standing water in the same pipe diameter. My slow trickle keeps the system live down to about 15 to 20 below zero without any intervention from me. Below that temperature, I take one additional step. I wrap the exposed sections of pipe near the cabin wall and near the spring catch box with dry grass bundles tied with rawhide. 6 inches of dry grass insulation around a copper pipe adds enough thermal resistance to keep the water moving down to about 35 below. I have only had the pipe freeze twice in 21 years, both times during extended cold snaps below 38 below that lasted more than 3 days. Both times I thawed it by building a small fire along the exposed section near the cabin wall. Took about 20 minutes. 2 interruptions in 21 years. My neighbor in the valley, who is on a well with an electric pump, has lost water at least a dozen times in the same period due to power outages, pump failures, and pressure tank malfunctions. His system cost $8,000 to install. Mine cost $5. Here is where I want to talk about something that most people in this country do not fully understand about their own water. Because once you understand it, you will never look at your faucet the same way. Municipal water in the United States is treated with chlorine or chloramine to kill bacteria. That is the part everyone knows. What most people do not know is that chlorine reacts with organic matter in the water to form compounds called trihalomethanes. The EPA has set a maximum contaminant level for trihalomethanes at 80 parts per billion. That number was not chosen because 80 parts per billion is safe. It was chosen because the water treatment industry lobbied the EPA during the regulatory process, and 80 parts per billion was the level that most existing treatment plants could achieve without expensive upgrades. The Environmental Working Group analyzed water quality data from over 48,000 water utilities serving 280 million Americans. They found that more than 80% of utilities delivered water containing trihalomethanes, many at levels that the EWG's own scientists consider a health concern based on peer-reviewed literature, even when those levels fall below the EPA's legally permissible maximum. The EPA's standard protects the industry's operating cost. It does not protect you. Then there is fluoride. Fluoride is added to the water supply of approximately 73% of Americans served by community water systems. The stated purpose is dental health. What is less frequently stated is that the fluoride used in water treatment is not pharmaceutical-grade sodium fluoride. It is hexafluorosilicic acid, a waste byproduct of the phosphate fertilizer industry. Before water fluoridation began in 1945, this compound was classified as an industrial pollutant. Disposing of it legally required expensive, hazardous waste handling. The fertilizer industry found that selling it to water utilities as a dental health additive was more profitable than paying to dispose of it safely. The raw material your city adds to your drinking water is purchased from fertilizer companies. That is not a conspiracy theory. That is the supply chain. You can verify it with a public records request to any water utility in the country. I drink water that has passed through 200 feet of granite. It contains no chlorine, no chloramine, no trihalomethanes, no fluoride, no pharmaceutical residues, no microplastics, no agricultural runoff. The mountain filtered it for free over the course of weeks and handed it to me at 38 degrees through a crack in the rock. I carried it 340 yards to my cabin through $5 worth of copper pipe, and I will drink it for the rest of my life without paying another cent. The bottled water industry generated $94 billion in global revenue in 2023. $94 billion for a product that falls from the sky, filters through the earth, and emerges from the ground in every mountain range on the continent. Dasani is municipal tap water from Detroit that has been filtered and sold at a 4,000% markup. Aquafina is municipal tap water from Wichita. Both companies have been fined for misleading consumers about the source of their water. You are paying $2 a bottle for the same tap water you are trying to avoid, packaged in a plastic bottle that leaches microplastics into the water as it sits on a shelf under fluorescent lights. A peer-reviewed study published in the Proceedings of the National Academy of Sciences in 2024 found an average of 240,000 detectable plastic fragments per liter of bottled water. 240,000 particles of plastic in every bottle. My spring has 0. I want to bring this back to something practical because I am not trying to scare you. I am trying to show you that the system most Americans depend on for something as basic as drinking water is more expensive, less reliable, and less clean than a hole in the ground and a piece of copper pipe. If you have access to land with any elevation change at all and a water source uphill of where you live, you can build what I built: a spring, a gravity feed, a catch box, and a spigot. No electricity, no pump, no monthly bill, no dependency on a utility that can raise your rates, contaminate your supply, or shut off your service. The knowledge to do this is not specialized. It is not complicated. A Roman farmer in the 1st century could have built my system in an afternoon. The only reason it feels exotic in 2026 is because someone figured out how to charge you monthly for something the earth gives you for free. Tell me in the comments where your water comes from. Not where your utility says it comes from, where it actually comes from. Because most people have never asked that question. And when you start asking it, the answers will change how you think about every bill that shows up in your mailbox. The next video is about something I have been asked about more than any other topic since I started sharing how I live up here: medicine. How I treat every injury, every illness, every infection on this mountain with no doctor within 50 miles. My medicine cabinet is the forest floor within 100 yards of my cabin. And what I have learned about what grows out there in 21 years would make a pharmacist question everything they were taught in school.